Hello everyone, this is Dr. Jawad. In this video I'm going to talk about bone tissue, and I'm going to go into the different structures of the bone. Now remember, bone tissue is a connective tissue, so what does that mean? Connective tissue is made up of cells, gels, and fibers. So when it comes to the bone tissue in of itself, there's the 4 different cell types. One, osteoprogenitor cells, which means it's the cells that are programmed to make bone. So those are the pre-bone cells, which will then turn into the osteoblasts, which are your immature cells. Remember, blast is immature, which then gradually turns into the osteocyte, which an osteocyte is a mature cell. And then as the mature cells kind of get old, we have these cells called osteoclasts. Osteoclasts, those cells are programmed to break down because we always want to build up and break down. You want this constant cycle, because if this cycle is disrupted, if one is going too far from the other, you're going to have brittle bones, or you're going to have too hard of a bone, kind of like ankylosing spondylitis, where you're just laying down more bone and those osteoclasts don't really work. So what's going to happen is that the bones eventually are going to fuse together. So those are the 4 cell types. Next is the gels and the fibers. Now 50% of your bones are water. So the gels and fibers, they make up about 30% of the remainder part of the bone, and this is strictly organic. Now the gels, it's a glycoprotein and a GAG, which is a glycoaminoglycans. And that actually makes about 30%. Now the fibers, this is organic. Now we have different type of protein fibers in our body. Collagen by far is always the strongest one. Okay, a lot of our tissues are made up of collagen fibers. Loose connective tissue is a lot of collagen fibers. So with the bone, we have the collagen fibers, which gives it a lot of its strength as well. Now that's 30%. So the remainder 70% of bone is the minerals. This is inorganic, hydroxyapatite, and those 2 ingredients that make up bone are calcium and phosphorus. This is why it's so important to have calcium and phosphorus in the diet, and because it does make up the ingredients for bone. So when we actually come to the structure of the bone, I'm talking about a long bone here. Let's start from the outside, from the ends in. So we have the 2 ends of the bone, and the 2 ends of the bone are called the epiphysis. Now we have a proximal epiphysis and we have a distal epiphysis. And the middle of the bone, the part of the bone that you grab, that's called the diaphysis. So the epiphysis are at the ends and the diaphysis is in the middle. And then we have this section which blends the 2. So the blending of the 2 is the metaphysis. Okay? So we got the diaphysis, which is the bone shaft. The end of the bones is the epiphysis, and in between the blend is the metaphysis. So then we talk about the structures, the outside structure of the bone. Now, remember, we all started off as hyaline cartilage models, which as we grew and we matured, the hyaline cartilage eventually turned into bone. So at the end of the bones, we have articular cartilage. The articular cartilage is still made up of hyaline cartilage, and we need the articular cartilage at the end of the bone because 2 bones together make up a joint, and it helps reduce joint friction. And that's all made of hyaline cartilage. Now when we get to the inside of the bone, there's 2 important parts of the bone that you need to know about that's important. One is spongy bone and the other one is compact bone or cortical bone, depending on how you're learning it. So the compact bone, that's the hard part of the bone, okay? And that is on the outside. That's compact bone, that's on the outside, and it's very, very hard. Now on the inside of the bone, sometimes on the ends of the bones and also on the inside of the bone, we have a soft, spongy bone full of trabeculae, which look like branches. That's spongy bone, it's soft. And this is where a lot of blood vessels are around it. So then when we have the structure of the bone, so then we let's peel open the bone, and that's the periosteum. The periosteum is the bone blanket. That's what I always refer to it as. And this is where a lot of the compact bone cells are developing. So we do have 2 forms of growth, one from the inside out, and also we have it from the outside to make it thicker. And this is the periosteum. The periosteum is the bone blanket. So when it comes to the compact bone, with the periosteum, you just peel it open, And you can see here that we have these circular rings. So with compact bone, it much looks like a tree. So when you cut down a tree and you look at the tree and you see all these rings, you have that central, the osteon, and you have all these nice blood vessels with inside it. But we have these mature bone cells called osteocytes that allow the bone to grow thicker and thicker and thicker, and that's a compact bone. We have this inner cavity called the medullary cavity. So we were going to open up the bone, and it looks kind of like an adult bone. It's the yellow bone marrow. So you have the medullary cavity, which is it contains a lot of the arteries and veins. And in the adult, what happens is this is the yellow bone fat. In infants, this is still red. It's still red bone marrow producing red blood cells, because as the infants are growing, not only are they growing long, but also too, eventually they're going to start growing thicker, and that's all due to the medullary cavity. And since we have a periosteum on the outside, on the inner side, which lines the medullary cavity lines, is the endosteum. Now, when it comes to the spongy bone, okay, we have the endosteum, which this is the growth from the inside out. And we have these certain cells. So we have these osteoprogenitor cells, which those are the bone-producing cells. And you can see here that you have the osteoprogenitor cells going in, forming the osteoblasts, which are the baby cells. And again, as they're growing, we have these osteoclasts that, again, they have to break down the bone in order for new bones to form. So we have this we have the epiphyseal line. So there's a line that separates the epiphysis from the metaphysis and the diaphysis, and these are basically the purpose of the epiphyseal line. These are the growth plates. So a lot of times if you're taking an x-ray, or if you could see an infant bone, you could see these lines, and you can really, it's pretty cool, but you can see where how much more growth they have. So the different structures of the bones as such. Now we have a main nutrient artery because these bones have to get their nutrients. So piercing in the diaphysis, the foramen, is the main, I would call the main arterial hub, which is a nutrient artery. And that dips down right into the diaphysis, the nutrient artery, which helps supply the inner bone with the nutrients. Okay? So I hope this helps. If you have any comments, leave them down below. I'll see you in the next video. Be good.